What is up guys, Crunchy Code Bits here. As you guys read from the title, we're going to be going over how to make a Minesweeper AI. But first, a little bit of backstory. I was first introduced to Minesweeper by a friend in high school. This friend, we'll call her Anna for the time being, was extremely good at Minesweeper. And when I say good, I mean she could likely go through a board of 100 mines in around 1 minute. And for all you Minesweeper stands out there that know the pain of misclicking or having a flag in the wrong spot, you know how extremely difficult that is. Now, with a bit of research, I found the world record attempt for 100 mines. The video, posted by Speed Demos Archives, featured a person completing Minesweeper in 31 seconds. Now, as I'm a student pursuing my BA in computer science and BS in statistical science, I was naturally inclined to ask the question, can I do better? And by me, I mean my computer, because I know I'm too dog to do it myself. I'll briefly explain a bit about the game as it's important in understanding the logic behind the AI. We are given a hidden grid of cells, with each cell representing either a mine or a number representing the number of mines surrounding it. The main strategy behind the game is to look for open cells where the number represented on the cell is equal to the amount of closed cells surrounding it. Now, with just that information, you would think it would be pretty easy to make an AI. We can iterate through the grid of cells, looking for cells that satisfy that condition, and for all cells satisfying that condition, we can add its nearby cells into a list of mines, while using that list of mines to deduce safe cells. Unfortunately, just like everything in life, it's not that simple. Let me show you what I mean. In this example, we have 4 open cells, and in fact, we actually cannot make a 100% guaranteed safe move, but we can deduce in which cells mines must be and probabilities of each cell being a mine. In this example, the cell 22 must be a mine. This is because between these 4 cells there has to be at least 2 mines. And as we can see, if there's 2 mines between these 4 cells, that only leaves 1 more spot for the 3rd mine to be in this cell. Now you might be wondering, okay, how would we encode this? Using that naive method that I described earlier, we wouldn't be able to deduce from the 1 cells that there are at least 2 mines in these 4 spots. This is because when we get to the 1 cells, we would see that there are 2 open spots but only 1 mine, and thus not be able to deduce the position of the mine and thus not encoding any information into our list of mines. So what we're going to do is use prepositional logic. I won't go too in depth here, but essentially we're going to take a given open cell and encode the information about the closed cells around it. Let me show you with an easier example. Take this grid with only 1 open cell with a value of 1. From this, we can infer this prepositional logic, which states that there could be a mine either in A, B, C, D, etc. But that's not actually all the knowledge that we know. In fact, we can actually infer a whole plethora of knowledge depicted here. Essentially what it's stating is, if we know, for example, A to be a mine, then we would know all the rest would not be mines. As you can see, this is a lot of knowledge just for 1 cell with 1 mine, and it's not too efficient. We're gonna have to find a better way to encode this in the computer. Luckily, there's a clever solution. We'll create something called a sentence, which represents a set of all the unopened cells surrounding that given cell, and a value representing that given cell. In the case of our example, our sentence would look like this. As you can see, this is way more efficient, and we can encode a whole grid of cells like this. If you want to learn more about prepositional logic, or the logic that went behind making this AI, you can refer to this course by Harvard called CS50 Introduction to Artificial Intelligence with Python. The course is very well taught, diving into topics like algorithmic thinking, machine learning, and neural networks. You can find a link to the Minesweeper project page down below. Now, with that piece of information, we have a good amount of the AI done. Another case that we're going to have to look out for is when the sentence count is equal to 0, because obviously that would mean all the cells inside that sentence are safe. And with just those two pieces of information, we have about 50% of the AI done. The last 50% are the sentences that are inferred. You see, Minesweeper is a game where you have to use all the cells to make an inference on the board. It's not enough to create a sentence for all the open cells. We also must iterate through every sentence in our knowledge base and check to see if there's a set of cells that is fully contained in another sentence set of cells. This will allow us to infer additional knowledge. Now, with the logic behind the AI done, let's get to making the game. For the Minesweeper game, we're going to have two implementations. Now, the reason why I'm doing this is because the CS50 course made the Minesweeper game in Python. The problem is, when you hit a 0 cell, it doesn't open all the surrounding cells that are also 0 until it reaches a line of mines. This is how the actual game plays and how my implementation in Java works. I know the reason why they didn't do it this way. It's because adding knowledge for all those open cells would be really time consuming, and so they made it easy. But I don't want to take the easy route, I want to take the hard route.
Fuel, give me fire, give me that which I desire. Ooh.
Now, I will have both of these implementations down in my GitHub, but for the sake of the video, I'm only going to be discussing the Python implementation, as it's a lot cleaner to look at. Honestly, I probably could have just left it at Python, because it really was a pain to get the implementation into Java. I kept getting this concurrent method exception, which I found out was caused by me updating the set while also iterating over it. That, plus getting myself somehow stuck in an infinite loop somehow, made the whole process really difficult. Luckily, there's a savior. The man, the myth, the legend. ChatGPT.
That's why he's the GOAT! The GOAT!
Honestly, I really only needed it for the concurrent method exception, as the logic, as I stated before, was really similar to Python. With its help, and with the test cases that I wrote for my Java implementation, and the test cases I used from the CS50 Python implementation, I knew I had a fully working Minesweeper AI. So, without further ado, here's the results. that wraps up the video, guys. As you guys saw, the Minesweeper AI wasn't 100% perfect. In fact, it wasn't even 50% perfect. This is because the AI has to make a random move every once in a while. Now, with the Python implementation, it wasn't a problem because the grid was small. However, in my Java implementation, I added 5 sizes. This greatly increases the amount of random moves that the Minesweeper AI has to make. Now, I was able to add a bit of code to my implementation to have my random move return the move that has the lowest probability of being a mine. This, however, was not enough to make my AI as accurate as I wanted it. Now, there's probably a million more things I could have encoded into this AI, but for the sake of my mentality, I'm gonna leave it at this. I hope you guys found this video interesting and you learned something new. I know Minesweeper isn't the most complicated game, but I really wanted to spend this time to learn animation software so I can make a good high quality video. In the future, I hope to look into reinforcement learning to make some pretty cool AIs. I will likely do a small reinforcement AI like a snake game, and then I have a really big project that I think you guys are really gonna like. So, if you learned something new or just got a laugh, please like, comment, and subscribe. I'll see you guys in the next video. Peace.